Hello, this is Science Demystified, your number one tutor on this channel. Today I'll be discussing with you the De-Broglie's wave theory. Now remember that the De-Broglie's wave theory holds that every particle, including you and I, because we are particles in the universe, okay? Every particle has some wave-like characteristics. Every particle you see has wave characteristics. And to prove this De-Broglie's wave theory, we need to start by looking at the Albert Einstein's equation and the Max Planck's equation, because that is what that will lead us to the derivations, okay? Now let's look at the Albert Einstein's equation. The Albert Einstein's equation says that the energy of emitted radiation can be calculated using E equals mc squared. This is Albert Einstein's equation. Then the Max Planck's equation holds that the energy of a photon can also be calculated using hf, where h here is called the Planck's constant and f here is called the frequency of the emitted radiation. Now, if we equate Albert Einstein's equation to Max Planck's equation, that will give us mc squared equals hf. Remember that there is a relationship between the frequency of radiation to the speed of the radiation and also the wavelength of the radiation. So if I turn my f, if I substitute f using speed over wavelength, that is frequency equals speed over wavelength. If I substitute for f, the equation becomes mc squared equals hv over what? Lambda. mc squared equals hv over lambda. Now you can see, though what I use here is c. In most textbooks, you see that this v is replaced with c. So whether it is c or v, it still means the same thing as speed, okay? It's still the same thing as speed. So from here, I can cancel one c and cancel one c here, so that I'm left with what? mc equals h over lambda, which is the wavelength. Okay? All right. So what is remaining in my equation is mc equals h over lambda, right? So I can decide now to make lambda the subject of the formula. So you can see that the wavelength here is equal to h over what? mc. And remember that in physics, the product of the mass of a body and its velocity is known as the momentum of the body. It's not the momentum of the body. So you can see outrightly that there is a relationship between wavelength and the momentum of a body. Now, every particle, what that makes a body, what that defines a body to be a particle is momentum. That is, a body is called a particle if it has momentum. So the P here, which is momentum, defines the particulate nature of the radiation, which is P. And then the wavelength here defines the wave form or the wave-like nature of the radiation. So this explains what we call the duality principle. That is the dual nature of matter. It shows that matter has some wave-like characteristics and some particulate characteristics as well. So that is what we mean by the dual nature of matter, or the duality principle. It means that you and I, we are particles and also waves at the same time. So we have wave-like characteristics and we also have particulate characteristics. So it is now left for you to explore your wave-like characteristics. So that one will be the discussion for another day. Okay? So from here, you can see what the De-Broglie's wave theory is all about, that the wavelength, every particle is associated with wave, characteristics. Now, I wouldn't want to take it down to the Niels Bohr's quantization theory, where he said that the wavelength of radiation emitted from an atom is quantized by a discrete value of nh over 2 pi. Okay? Now, that also suggests that the energy emitted from atoms are discreted, which also proves the quantum theory of matter. So I'll see you in my next video. Please, if this is the first time you're watching me right on this channel, this is the Science Demystifier. Please do well to follow, do well to share, like our videos. And also we're on YouTube. You can go to my YouTube page, look for the Science Demystifiers lesson or academic platform. Click on the bell notification for updates, subscribe and share. God bless you.